I want to talk about indefinite integrals, and they definitely rely on the antiderivative. So let's talk about the antiderivative. If you have x to the n, the antiderivative is x to the n plus 1 over n plus 1. This is the um, power rule for antiderivatives. If you have something like x to the, like for example, x to the 3, this is x to the 4th over 4. If you have a square root of x, this is also known as, there's a 2 here, there's a 1 here, this x to the 1/2 power. So this would become x to the 1/2 plus 1 over x over 1/2 plus 1. And then so this would be x to the 3/2 over 3/2, which would be 2/3 x to the 3/2. And then you'd want to simplify this as 2/3. This is the square root of x to the 3rd. It's 2/3 out front. And then x to the 3rd is also known as x squared times x and the square root. So that little x squared can come out as just an x. So it'd be square root of x. So this would be 2/3 x to the times the square root of x. All right. So the indefinite integral, an example of this would be something like integral x to the 1.9 plus x to the 3.5 dx. So the dx is there because it comes from that delta x in the integration formula where you're finding the rectangles, right? So you don't really need to worry about it too much. It just tells you what the variable is. So we're going to use a power rule here. So it's x to the 1.9 plus 1 over 1.9 plus 1 plus, and then let me make this a little thinner, x to the 3.5 plus 1 over 3.5 plus 1. Now then you got to add a constant because, well, I'll tell you why in a second. So now this is x to the 2.9 over 2.9 plus x to the 4.5 over 4.5 plus c. You add the c because whenever you take the derivative, you have to get what's inside. And there could have been a constant there. And when you take the derivative of a constant, that's 0. So you just add the constant in there, and that'll go away whenever we talk about definite integrals. So then another problem in the homework would be something like the integral of the 6th root of x to the, I don't know, 7th. So dx. So you would immediately make this into a power 7 over 6 dx. And now you take the integral x to the 7/6 plus 1 over 7/6 plus 1 plus c, and then you simplify it from there. And another problem that you might see in the homework would be something like this: integral of x plus 2 times x minus 3 dx. Now, one of the main things that students do wrong is they take the integral of each and then they multiply. That's not what you do. It should be x squared over 2. X squared over 2 and then minus 3x, and then they multiply all this mess out. That's not what you do, because the integral of a function times another function dx, like you have, this is f and this one's g, the integral is not equal to the integral of the first one plus the integral of the times the integral of the second one. Plus works, times doesn't. Okay, so just add g of dx. All right, and so what you would be doing by integrating each one inside here is assuming this is true, and it's not. So what you do is you multiply it out. All right, so you multiply out x squared minus 3x plus 2x minus 6 dx, and then you simplify it, and then you take each one separately. Okay, so you'll use the power rule here. Another one that you might see in the homework is like the integral of 2 plus the square root of x plus x all over x dx. Now, if you notice, there's a function on the top and there's a function on the bottom. And remember, when you took the derivative of the power of the quotient, this was not the derivative of the top over the derivative of the bottom, right? It was f prime g minus g f prime over g squared. That was the derivative of this. So it's the same idea here. You can't just take the integral, if you have the integral of a function on top and then an integral of a function on the bottom, this is not the integral of the top over the integral of the bottom. Okay, so don't ever do that. There may be one case in which that works, but otherwise it doesn't. So what you would do here instead is you would go ahead and split it up because it's a fraction. This is 2 over x plus square root of x over x plus x over x is 1. This is dx. And now you just work with these separately. Now this one here is x to the 1/2 over x to the 1, which would be x to the negative 1/2 when you use the power rule from algebra. And so you'll use the power rule for integration there. This 2 over x, this is like 2 times 1 over x. And remember, the antiderivative of 1 over x is natural log of x. So this would be 2 natural log of x in absolute value. The integral of that would be. And then the integral of this one would just be x. Now let's talk about this one here for a second. Let me pull this over. When you have integral of 2 over x dx, you may be thinking that you can use the power rule here. This is x to the 1. So this is integral of 2x to the negative 1 dx. And then when you use the power rule, it'd be 2x to the negative 1 plus 1 over negative 1 plus 1, right? But the problem is that's x to the 0 over 0. And 0 in the bottom, you don't like that, okay? So it turns out to be natural log. That saves the day there. All right, so that's that one. And then you might also see, something like integral of sine x plus hyperbolic sine of x. And so you just use your antiderivative properties here, okay? This one here is hyperbolic cosine of x. This one here is negative cosine of x plus x, and then plus c, right? You might also see something like, remember that, you might also see something like integral of secant of t times secant of t plus tangent of t, all right, dt. So remember, you don't just take the integral of each one. In fact, the integral at first, we're going to get to in Cal 2. So you multiply this through, and then you'll see that these are antiderivatives. I'm sorry, these are derivatives of functions that you've seen before. All right? So just look in your trig tables if you want. You might also see something like this one, sine of 2x over sine of x dx. Now, whatever you do, please don't cancel this, okay? You have to write it. You have to remember the double angle formula for sine of x. And then sine of 2x, sorry, sine of 2x. So sine of 2x is sine x cosine x. And then you simplify it from there. We'll let you figure that out, all right? Now, that does it for indefinite integrals. And I think what I want to do in the next video is talk about some definite integrals.